So we're gonna start a new lesson 6.3. It's ratios and identities. I'll start first. No, the first part is about the four quadrants and the unit circle. What does it mean, unit circle? First, when I say unit circle, it means the radius of the circle is 1 unit. So I have a circle. The radius of the circle is 1 unit. So if I have from here to here, the distance is 1 unit. From here till here, the distance is 1 unit. So if I draw here a right triangle, I know that the hypotenuse of this right triangle is 1, so it's 1 unit. And if I have an angle here, theta here, it's a 90 degree. So what is sine? We know that SOHCAHTOA, sine, it's opposite over hypotenuse. I don't need this part, that's why I'm erasing it. So opposite, what is the opposite side here? The opposite, it's y, because this is the y-axis. So it's y over 1. So sine theta is y. That's why the y-axis represents the sine of the angle. And if I say cosine is adjacent over hypotenuse, this is the adjacent x over the hypotenuse 1. So the cosine theta is x. That's why the x-axis represents the cosine of the angle, and the y-axis represents the sine of the angle. Now, from this information here, I can deduce a famous relation between sine squared theta and cosine squared theta. If I want to find what is sine squared theta plus cosine squared theta, so it is x squared plus y squared. And then if I look now, what is x squared plus y squared? This is x squared plus y squared. So using Pythagoras, we know that side squared plus side squared equal to hypotenuse squared, so it's equal to 1. That's why we have all the time that sine squared theta plus cosine squared theta is equal to 1. So from here, this famous formula that you know it since grade 9 comes. So we know now that sine squared theta plus cosine squared theta is equal to 1 comes from this unit circle. Let's move to the quadrants. We go from left to right. So now I have here, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if I'm standing here and I do the orthogonal projection, so I can find the cosine, and I know that this is 0, guys, here. So here it's a positive, here it's positive, this side here is negative, and this side here is negative. So if I'm quadrant 1, the orthogonal projection for the cosine, this is cosine, we said, and this is sine. It's positive and the sine is positive. If I'm standing in quadrant 2, the cosine is negative and the sine is positive. How do you know the sine of the tangent? It's sine over cosine. We know that tangent alpha or tangent of any angle, it's sine alpha over cosine alpha. And you know that cotangent, it's 1 over tangent, or also it's cosine alpha over sine alpha. So tangent and cotangent, they will have the same sign all the time. And to find what is tangent, it's plus over plus, so it's plus. So sine is positive, cosine is positive, tangent is positive. In quadrant 2, cosine is negative, sine is positive, tangent is negative, because plus over minus, it's minus. In quadrant 3, now this is cosine is negative, sine is negative, so tangent is positive, minus over minus plus. And quadrant 4, cosine is positive and sine is negative, and tangent is negative because also minus over plus gives me minus. Now let's move to the particular angle, and this is very important. This is my pizza, and I can cut this pizza in many pieces. If I want to cut this pizza in equal pieces, and it's on 12 equal pieces, the angle will be 30 degrees. So it's 30, 30, 30, because the total, we know that the total of all the angle, the sum of that is 360 degrees. So each angle gonna be here 30, 30, 30 degrees. Now, for each angle, we have different sine and cosine. But how are we going to find that? First, I need to know. So if I take this triangle outside, when I say cosine and sine, it means cosine, I want to find this distance, the x, and sine, I want to find the y. So let's take this triangle out. If I take it out from the unit circle, it's a right triangle, guys. If this angle is 30 and here is 90, so here is 60. So if I will name this angle ABC, so we call it, it's a semi-equilateral triangle. And we know that, I'm sorry, the pen is, that the hypotenuse is 1. It was an equilateral triangle, so it was like this, guys. So it means that this one was 1 and this one was 1. But when I cut it in half, this one becomes half. So it means that this distance here is half. So I can say that if I'm standing here, so what is cosine 30 or what is cosine pi over 6? It's half. Now, how do I find the distance AB? I can do Pythagoras to find this distance. If I do Pythagoras, it gives me that AB squared is equal to half squared. Sorry, guys, for the handwriting. It gives me half squared minus 1. Sorry, 1 minus half squared. It's 1 squared minus half squared. So it will give me that AB squared is 1 minus 1 over 4. Same denominator, 3 over 4. So what's going to be the distance AB? It's radical 3 over 2. Okay, excellent. It means that, I'm sorry for the handwriting, guys, that this one is radical 3 over 2. And now, if I want to find what is this distance here, so it's radical 3 over 2. So now, what is cosine 30? It's radical 3 over 2. So the orthogonal projection over the x-axis, I don't know if I said before it's half, I'm sorry. And the sine, the y is half. So if I want to move, it's each angle is 30. It means if this is 30, this one gonna be 60. So if I want to use the radian, so this is pi over 0, pi over 6. This one we said it's 2 pi over 6. What does it mean 2 pi over 6? It's pi over 3. 3 pi over 6. 3 pi over 6 means it's pi over 2. This one is 4 pi over 6. If I simplify, it's gonna be 2 pi over 3. This one is 5 pi over 6. This angle is 6 pi over 6 means pi. This one is 7 pi over 6. This is 8 pi over 6. If I simplify it, it's 4 pi over 3. 9 pi over 6. This one is 9 pi over 6. If I divide it, it's 3 pi over 2. This is 10 pi over 6. And if I simplify it by 2, it's going to be 5 pi over 3. This is 11 pi over 6. And this one is 12 pi over 6. It means it's 2 pi. So each small angle is 30 degrees. So I have pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. So those are all the sisters of pi over 6 and pi over 3. And each one, it's either half or radical 3 over 2. If I do the orthogonal projection here for the cosine, the distance is half. The sine is radical 3 over 2. And you need to check the sine. If I go to this one here, orthogonal projection, so cosine, it's negative, so it's minus half. The sine is positive, radical 3 over 2. If I do the orthogonal projection of this point here, the distance here is, I can see it, it's minus radical 3 over 2. The cosine, the sine is half. When you do more practice, guys, you will get it easily. I will do the same thing for now pi over 4. I cut this pizza in, just I wanted to be 16 pieces, okay? So each angle is pi over 4. Again, I'll do the particular, this is 0. Pi over 4. 2 pi over 4, it means it's pi over 2. This is 3 pi over 4. This is 4 pi over 4, it means it's pi. 5 pi over 4. This is 6 pi over 4, it means it's 3 pi over 2. 5 pi over 4. This is 7 pi over 4. And this is 8 pi over 4. It means it's also 2 pi. And again, I didn't mention that, but this, if I'm standing here, what are the coordinates of this point? This is 1, 0. So that's why cosine 0 is 1, sine 0 is 0. When I'm standing here, the coordinate of this point is 0, 1. So cosine pi over 2 is 0, sine pi over 2 is 1. If I'm standing here, it's the coordinate of this point here, it's minus 1, 0. So that's why cosine pi is minus 1, sine pi is 0. And then when I'm standing here, this is 0 minus 1. That's why when I'm mentioning the cosine of 3 pi over 2 is 0 and sine is minus 1. Now my objective is to find what is the distance here. Let me change the color. What is the measure of this length and this length? If I take out this triangle here, this triangle is a right isosceles triangle. So, and this is 1. This is x and this is x. Here it's 90 degree, 45, 45. So if I do Pythagoras, x squared plus x squared is equal to 1. So 2x squared is 1. X squared is half. It means x is radical 2 over 2. So it means now all the coordinates are radical 2 over 2, but either positive or negative. Here it's radical 2 over 2, radical 2 over 2. Here the cosine is negative, minus radical 2 over 2, radical 2 over 2. When I'm standing here, the cosine is negative and the sine is negative, so minus radical 2 over 2, minus radical 2 over 2. And when I'm standing here, the cosine is positive, radical 2 over 2, minus radical 2 over 2. So as a summary, all the sisters and the brothers of pi over 6 and pi over 3, the values of the sine and the cosine are either radical 3 over 2, either half. So either the distance from either y is half and x is radical 3 over 2, or the opposite, like here, y is radical 3 over 2 and x is half. And all the sisters of pi over 4 are radical 2 over 2, radical 2 over 2, but we need to focus if it's positive or negative. Let's move to some formulas. It's also easy. What is the relation between theta and minus theta? You see that I'm taking all the time theta in quadrant 1. Even if I took theta in another quadrant, the relation between theta and minus theta gonna be the same. They're gonna have all the time the same cosine, opposite sign. So I will show you how. If I'm standing here and this is theta, so when I'm going this side, so it's positive. When I'm going this side, it's negative. So if I say this is the angle 30, for example, minus 30, I'm gonna go down. If I do the orthogonal projection to see the cosine of theta, it's this distance here, the pink one. And what is the cosine of minus theta? It's all the same. So cosine minus theta is the same as cosine. Now, if I do the orthogonal projection to find sine, what is sine theta? That's it. It's here. Did you see it? And what is sine minus theta? Are the same? They are not the same. It's the same distance, but they are opposite. So it's minus sine theta. Again and again. If this is theta, pi plus theta, it means it's theta plus pi, it's 180. So it's going to be in quadrant 3. If this is 30, 180 plus 30 is going to be in quadrant 3. Let's compare the cosine. This is cosine theta, and here is cosine pi plus theta. Is it the same? No, they are opposite. So this is minus cosine theta. And let's see the sine. Orthogonal projection over y. This is the sine theta, and this one is a sine minus theta. They are the same. No, they are opposite, so it's minus sine theta. Let's move to pi minus theta. If this is theta, this is pi minus theta. This is pi minus theta. So the cosine theta, it's this distance here. The cosine pi minus theta, it's this distance here. They are opposite, so it's minus cosine theta. Now let's see the sine. Orthogonal projection, this is the sine theta. Orthogonal projection, this is the sine pi minus theta. So it's the same. So it's sine theta. Now let's move to pi over 2 plus theta and pi over 2 minus theta. Pi over 2 plus theta, it's going to be in quadrant 2. So, but I'm adding pi over 2. So if this is theta plus pi over 2, it's going to be here. If I want to compare the cosine, they are not the same distance. So they are not equal. But if you compare the cosine theta and the sine theta, they have the same distance. From here till here and from here till here, it's the same distance. So it's the same distance as sine theta. But let us see the cosine pi over 2 plus theta. Does it give me a negative or a positive answer? The cosine is here. It gives me a negative answer. So it's minus sine theta. Sine pi over 2 plus theta. First, does it give me a negative or a positive answer? It gives me a positive answer. And this distance here, it's like the cosine. So it's plus cosine theta. Again here, pi over 2 minus theta. The cosine gives me a positive answer, and the sine gives me a positive answer. But the distance of the cosine, that's it here. If I do it in yellow, this distance here is equivalent, it's equal to the sine theta. So this is sine theta. And if I want to see the cosine pi over 2, the sine pi over 2 minus theta, this distance here, it's equal to the sine theta. So this is plus the cosine, sorry, this is plus cosine theta. So when it's pi over 2 plus theta or pi over 2 minus theta, it's switched. The cosine becomes sine and the sine becomes cosine. For the last part, how to solve trigonometric equations, you will see it more in the application. When I'm solving an equation with cosine, I should write it as cosine equal cosine. And which two angles I have the same cosine? Just alpha and minus alpha, or theta minus theta. So when I'm solving cosine equal cosine, the angles that are equal or minus alpha plus 2k pi. Why would we write plus 2k pi? It means it's number of turns. I can stand here and I can do a whole turn, two turns, three turns. When I'm solving sine, the angles are equal if it's alpha and pi minus alpha. Just this angle here and pi minus alpha, both they have the same sign. Look at it, it's here. So when I'm solving equation with sine, it's alpha plus 2k pi or pi minus alpha plus 2k pi. You're gonna see this more in the application. And when I'm doing tangent, it's just alpha plus k pi. Why? Because guys, if you are here or here,